Hello everybody, this is Itsu again. I also got a reaction on one of my videos on YouTube from T1000, and he asked me to do some testing because he's seen the video, the TK6 video, and I not really agree with him, but I think that the 1667 kHz is the natural resonance frequency of the 1.5 turn coil, and has nothing to do with the resonance of the yoke of the ferrite. But I can give it a try. He asked me to put 1.667 kHz square wave 39 duty cycle on the copper strip, and then look at the lower harmonics of the 50 turn coil with highest peaks. So I put my Chinese function generator at 1667 kHz, square wave duty cycle 39%, and I put it in to the copper strip. And I measure on the red probe the 50 turn coil, and I'm looking now at the spectrum of this. What I see here is the big spike. This is the 1.667 frequency I put in on the copper plate. Midpoint at the moment is 1.24 megahertz. And I'm at 250 kHz per division. I can put this in the middle, and you can see this is the 167 kHz I put in on the copper strip, so no surprises there. I see in the middle of the 1.24 megahertz, I see also a spike, but that is the resonance frequency of my 50 turn coil where I'm now measuring. I calculated that before here. The 50 turns is 1.2494 megahertz, and that's where we almost are. So he wants me to look at the lower harmonics of this 1667 kHz signal I put in on the copper plate. So I go one step down, and I have here now a nice peak. I'm now at midpoint 620 kHz. So that would be something like 800, and I have here 1 point. So I have several lower harmonics. I can go one scale down, and the midpoint here is 248 kHz, and I see a nice spike there. I will put it into the middle, and you can see it is 334 kHz. And when I divide my 1667 by 5, I get this 334. So I think this is the fifth harmonics, or I'm the 334 is the yeah, it's the fifth harmonic of this 1667. So this could be one of the lower harmonics of interest. So I will put this as being one of the things I have to look at. The next step T1000 asked me to do is then put that square wave frequency with 39 duty cycles on 50 turn coil and adjust to get the sine wave. So I will readjust my function generator to put in square wave. At 334 kilohertz. It's still on square wave. It's 39 duty cycle. I remove it from the copper strip and I put it onto the 50 turn coil. Black on black. And then I will switch off the FTT and look what kind of signal I got here. This is my 14 volts 334 kilohertz square wave frequency, 39%, and I will move my probe now to the bifilar output coil and see what I have there. I have something like a sine wave there. It's 48 volts peak to peak, and it's the same 334 kilohertz frequency, and I will now tune to get a maximum output. That was the idea for T1000. And I'm going now up in, what is it? I'm going down in frequency to adjust the scope a little bit. I'm now at 148 volts. And this is the peak I am now at the moment. The peak to peak is 188 volts. It's a nice sine wave. The frequency is 272 kilohertz, and that is the frequency I measured before. I think that's a resonance point of the bifilar coil, I'm not sure. But this is what I put in, 273 kilohertz. The next thing he asked is to put on the 50 hertz on the 15 turn coil and see what's happening then. So I have a AC adapter, 12 volt AC, because when I put in 50 volts for 50 hertz for my sine wave, nothing happens, it's too weak. So I will put my 50 hertz, it's about 12 volts peak to peak, with my bulb in series on the 15 turn coil. The bulb gets lit. It protects my my transformer. And now I am at the output. I want to measure the 50 hertz. See what kind of signal I've got there. Put my other probe on it. Put it on. And you see I have I'm measuring now the yellow probe on the 15 turns, and you see I have the square wave from the function generator put on the 50 turn coil, nicely being transferred. But I'm looking for 50 hertz now. I have to decrease the output from this function generator from the 273 kilohertz to be able to see something of a frequency on the 50 hertz. There's something. So the lower waveform now is the 50 hertz supplied by the transformer on the 15 turns. It's not much, it's 400 millivolts. But this is the best I can get on this low impedance 15 turn coil. I will now increase again the 273 kilohertz, and you see right away that it's also visible on the 50 turns because of the coupling. But we are interested only in the output coil, the red one. I will decrease the 50 turn, increase again. And we see some 50 hertz ripple going on there, but it's very, very weak. And we still have the nice sine wave of 167 now. I can tune a little bit, but it's not getting to get any better. So this is what T1000 asked me to do and to check. I have nothing on the copper strip. It's hanging loose. I have 50 hertz from my transformer in series with a lamp on the 15 turn coil, and I have my yellow probe on it. And it gives me now also the square wave input. And I have the function generator tuned for maximum output on the 50 turn coil at the outside. So I have some nice voltages, but it's only voltage. There's no, when I put a lamp on there, it's collapsed completely. There's nothing of power there. Okay, that's my little experiment with what T1000 asked me to do. Thank you for watching.